Hey everybody, Mr. Ian here. And if we're watching this video, you know that we're looking to model what's going on with our space pod and space station, and more specifically, why its velocity has changed during those missing signal moments. So today we're going to be talking about how you're going to be modeling the velocity changes of objects with different masses. So what we know leading up to that lost signal time. As scientists, we know that we need to apply our understanding of key concepts to help us explain our space pod problem and make sense of what's happening. So, if we're looking at our comic here, starting at time number 1, we know the pod was approaching the space station with a medium velocity and an unknown amount of asteroids. So, it could be a lot, could be a little, could have a lot of mass, could have very little mass. The thrusters exerted the same amount of force as a normal mission. So we know normal amount of force. Then at time 3, we know the ground team lost the video signal with the pod before docking was able to begin. And then at time 4, we know the pod was traveling away from the station with an unknown amount of velocity. Might be moving fast, might be moving slow. We don't know. Now, if we know the same strength force was applied to the pod at time number 2 with an unknown amount of asteroids when it first approached at time 1, how could the different masses cause the velocity change in our pod from time 1 to time 4? So when we say different masses, we mean a pod with more asteroids or a pod with less asteroids. To answer this, we have our ground team's 2 claims as the best reason for why the pod changes velocity. But now that we have more information, we need to think about how the different amount of asteroids could make both of our claims true. So those claims are the thrusters cause the pod to move in the opposite direction, thinking about the amount of asteroids, or the pod only slowed down the pod, so meaning it would keep going and later then bounce off the station. So today, you'll need to model how the space pod with 2 different masses could make both claims true. To do that, you're creating 2 models for our 2 claims in our modeling tool. So we're going to be modeling how the different masses could explain claim 1 and claim 2 using our modeling tool that we've done in the past for that lost signal time. So let's take a look at the features in our modeling tool. So when you come into our modeling tool, you're going to see there's a top row and a bottom row. The top row is going to show a bunch of important information that happened for the normal docking sequence. Okay. You'll notice here in the very beginning in the before force column, we have a medium dark circle, a blue velocity tail. We have pink arrows in the during force part, and then here we have nothing, okay, in terms of velocity or force arrows. And if you notice, it's showing that the pod had a medium velocity, okay, we see that with the medium velocity tail here. It had a medium mass, okay, which we show here with object B for looking at our mass objects, and the medium thruster force was normal, allowing it to dock. Okay, so that's what should have happened. We are going to have to model claim 1 and claim 2 below it. So to do that, to model both claims, okay, in the second row, you're going to need to use our objects here that represent the different masses you'll need to pull into all 3 of our boxes for both claims to be true. So you'll do a model for claim 1 and then a model for claim 2. You're then going to need to show the velocity details before and after the thruster force was applied. And then here in the middle, during force, this is where you're going to show the thruster force that occurred during the docking sequence or during those lost signal times. Now remember, you're modeling both claims. So you're going to have to ask yourself for claim 1 and claim 2, what mass will you need in each box to represent our pod with too much asteroids or too little? What force will you need to use to represent that normal thruster force during the mission? And then what velocity would you need at the start, before force, and end, after force, to show both claim 1 and claim 2? Okay. So you're asking yourself as you're completing these models, how will you use the features in the modeling tool, so our massed objects, our force arrows, and our velocity details, to show the effects of the thruster force on the velocity of the pod when it's more massive or less massive. Okay. Thinking about our key concept, if the same strength force is exerted on two objects, but the objects have different masses, the object with less mass will have a greater velocity change. So thinking about the different masses of our pod, thinking about our key concept, your job will be to model the first claim in pink, thrusters cause the pod to move in opposite direction, or the second one, the pod was only slowed by the thrusters. It kept going and then later bounced off the station. So, ladies and gentlemen, take a look at your survey. Do we understand how to use the features? Do we understand how to model the different claims? Okay. Do we understand the features we saw today, from the massed objects, the force arrows, the velocity details, and how to put them in the different boxes? Do we understand how to model our two claims? Okay, the one about the thrusters causing the pod to move away, the other about the pod only slowing and then later hitting off the station. Go ahead and complete your survey. Reach out if you have questions, and good luck.